In this video, I'm going to demonstrate how gamma correction inside a 3D application is often necessary, but can cause problems at other times. So here we have a render from 3ds Max. You can see that the scene consists of two flat plane objects, and they have this photo applied to them as a color texture. However, one of them looks normal, and the other one looks very washed out. This is because 3ds Max is currently set up to assume that any incoming bitmap needs to be gamma adjusted before the final render. It's because the final render will have its own gamma adjustment, so any adjustments before the final render need to be removed. So this image here on the left shows the default behavior in this scenario. The photo is imported into 3ds Max, and 3ds Max will darken the midtones by applying an inverse gamma correction. So this will make the photo appear dark, but in the end, the final render, what you see here, will bring the midtones back up to the normal level. Now this image on the right, it was brought into 3ds Max, but then I manually undid the gamma adjustment that 3ds Max applied. So this results in a double gamma adjustment at the time of the final render, which is why it looks washed out. It doesn't look right, but sometimes when you're using bitmaps for things other than color textures, like a displacement map or a bump map, you want to make sure that 3ds Max or whatever program you're using doesn't change the original gamma values in the bitmap. So to demonstrate a situation in which you don't want 3ds Max or whatever program you're using messing with the gamma values is something like this. Let's say I have a plane object and I want to apply this image as a displacement map, and I want it to result in a perfectly shaped hemisphere, which is half of a full sphere. I want it to be nice and perfectly round based on this image. So let's take a closer look at this image. You can see that in the middle of the image, the color values are full 255, which is full white. And in the edges of the image, it tapers off to full black, which is 0. So we're going from 255 to 0. In 3ds Max or Maya, it would be going from 1 to 0. It's the same thing, just different numbers to represent it. And the values in between are the correct values that correspond to a perfectly round sphere. It's hard to tell from this image, so let's see what the color values look like when they're graphed out. So this graph represents the locations from the center of the image to the edge, where the center of the image is full white and the edge is full black. Each mark represents a distance of 32 pixels, so you can assume that it's going from 0 to 255, which is 256 pixels. So from here to here is 512 pixels, so our image is going to be 512 by 512. And at each mark, I recorded the corresponding grayscale color value up here. For example, if I take the upper right quadrant of this image and place a guide at 32 pixels in, if I record this color value, it's 254. So let's find the 32 pixel mark on the graph, and you'll see that I've plotted a value of 254 up here. If you repeat that for the rest of the marks, you'll see that a perfect circle is formed by the values that you plot. So this means that if this image is used properly as a displacement map, then it should displace a mesh in the form of a perfect hemisphere. So let's try it out. We need to make sure that we start with a flat plane object that's 2 units by 2 units in size. This is because our bitmap represents only the radius of the full sphere. Since the values in the bitmap go from 0 to 255, which is the same as 0 to 1 in 3ds Max or Maya, the resulting radius of our hemisphere will be 1. So the plane, in order to look properly proportional, should be twice the radius, which would be 2 units. And you need to make sure that you have enough segments so that it's going to deform properly when you apply the displacement map. So let's try applying our bitmap to this mesh. We're going to choose Displace, add our bitmap, set the strength to 1, and there it is. Now you probably noticed that this does not look very much like a hemisphere. It looks kind of pointy. It doesn't look right. Let's see what happens if we try the same thing in Maya. Here's our sphere. Apply our bitmap. Adjust the tiling here. There we go. That looks good. So what's the difference? The difference is Maya is not using any kind of assumed gamma correction, and 3ds Max currently is. If we go back into 3ds Max, you can see that the image is being modified, and that's because our gamma correction is enabled, and it's affecting images that come in. It's assuming they have a 2.2 gamma applied to them, and it's going to get rid of that gamma. In effect, what that does is it takes our image and it applies an inverse of 2.2, which is 0.45, and our image looks like this now. We still have full white in the middle and we have full black on the edges, but all our midtones have been brought down a little bit. And what that does, instead of our graph looking like this, as soon as it does that, our graph now looks like this. You can see it tapers off faster, and it's going to result in a much pointier looking hemisphere, which is what we had. There's multiple ways to fix it. One way is to go into your material editor, and we need to drag our map in here. Here's our bitmap. You can add a color correction. So we'll plug our bitmap into the color correction. Come down here to Advanced and Gamma Contrast. I'm going to set this, right now it's set to 1, which is no change. I'm going to put it back to 2.2 where it should have been. You'll see it updated. And now all we have to do is assign this new color corrected image to our displacement map. So I'm just going to remove map and then drag this one right onto it. And now you'll see it looks a lot better. So you need to be aware that when using bitmaps for things other than color textures, it's important to keep gamma correction in mind so you get the results you originally intended.